Hi everybody, welcome to this section 2.2 video, and in this section we're going to be covering separable equations. Okay, so let's look at the learning objectives for this section. So we're going to define first order differential equations that are separable, and then we're going to solve separable differential equations, and then we're going to solve some initial value problems using this separation method. Okay, so separation of variables. So we begin this section and our journey in this class to solving differential equations with the most simplest way of all. Okay, this is our first analytical way to solve a differential equation, and that is with separable variables. So this is maybe something that you hopefully learned in Calc 2, just one way to solve differential equation analytically. You saw one graphically with solution curves and direction fields, hopefully in Calc 2 as well, and in our last couple videos. But here's the way we're going to solve this analytically, okay? Essentially by hand. So separation of variables requires a lot of integration. Okay, that's the main idea. We're going to integrate these differential equations. So while we're learning this, it's important to refresh yourself on some past integration techniques that you learned, like integration by parts, or use substitution, or natural log, you know, something like integral of 1 over u, natural log of u. So it's important to remember some integration techniques because that's what we're going to be moving into for the next chunk of content. So let's go ahead and define separable equations, something you've hopefully have seen in Calc 2, but we'll redefine it as well. So separable equations. So a first order differential equation of the form some derivative dy over dx, some function of y and some function of x. Okay, they're multiplying each other. This is said to be a separable differential equation or have separable variables. Okay, so what does that mean? What that means is that this is written as a product. The two functions are written as a product. Some function of x, some function of y can be written as a product. There might be some manipulation that might need to be involved in order to have it clear as a product, but that's what the definition is of a separable variable. Okay, so here's the goal. To solve any differential equation that looks like a separable variable. So what we're going to do is just separate out the function in terms of x, put that with the differential dx, and same thing with the y function. Separate that, put it with the differential dy. And then we're just going to integrate both sides with respect to the variable. Okay, so that's the goal. We're trying to separate and integrate and get some specific solution. So before we even do that, let's sort of determine what makes a differential equation separable or not separable. So we have two equations on the left and right. One is separable and one is not separable. We're already saying what they are. The left one is separable and the right one is not separable. Okay, so why is that the case? So let's try to play around with the left-hand side. So say I move the dx to both sides, right? I multiply both sides by dx. So then I'd be left with dy equals y squared, x. And I'm going to play around with this a little more. I'm going to separate out the powers of e to the 3x plus 4y. Exponential powers, since they're being added with the same base, we can take them apart and just multiply. And it would be by that dx we just multiply to both sides. Okay, so now what I'm going to do is divide both sides. I'm going to clear out all my y terms to the left side. So I'm going to divide by y squared e to the 4y. All right, and so what I'm left with is dy over y squared e to the 4y equals x e to the 3x dx. So that's why it's separable. I moved all my y terms to the left side. I have my dy there, and I moved all my x terms to the right side with my dx. So it is separable. Okay, so let's check out this right equation now. dy over dx equals y plus sine x. This is not separable. We already identified that. But why is that the case? Okay, so immediately the reason why is because I have this plus sign right here. Okay, they're not a product of each other. It's not y times sine of x, they're being added. But let's see mathematically like why this would be an issue. Okay, so let's say same thing, I move the dx over to the right hand side. Let me erase this really quick. So let's say I'm try to clear out this dx. Okay, and what I'm left with is dy equals y plus sine x, and it's all times dx. Okay, what else can I do? Maybe I could distribute in. Let's see if that will do anything. dy equals y dx plus sine dx. Okay, still we don't know what we can't integrate yet. Not everything is in terms of y or x respectively on either side. So I don't know, let's try to move that y over. So minus y dx minus y dx. And so what I'm left with is dy minus y dx equals sine dx, and this is just not going to work out. I have a dx attached to the y. I can't isolate the y terms. It's still like dy minus y. So it's not working out, and we can't separate these, and so this is just non-separable. Okay, so those are just two examples of separable, non-separable, and really the key indicator was just this plus sign here. It's just meeting the not meeting the criteria of being a product. Okay. Uh, so in the next video, we'll check out some examples, but that's it for this one. And take care. I'll see you in the next video. Okay.